The competition for artificial intelligence dominance is entering a physical phase. Companies are now competing for three specific things: electricity, water, and land. This scale shows the energy required for our daily digital habits. A standard Google search barely registers, but generating a 100-word response from ChatGPT requires 10 times the electricity. That computation generates heat. To keep the hardware from failing, that same 100-word response requires half a liter of drinking water for cooling. At scale, a single average data center consumes 500,000 gallons of water every day. Data centers already use up to 1.5% of all global electricity. As the demand for AI accelerates, national power grids are struggling to expand fast enough to support the necessary hardware. This suggests the ultimate limit for artificial intelligence isn't software capability. It is the availability of physical resources on a finite planet. Major players like Meta, Google, and OpenAI are currently hitting a wall. In many regions, securing the land and environmental permits for a new terrestrial data center can take between 5 and 10 years, often facing significant local community pushback. This scarcity has forced leaders to seek unprecedented capital. Sam Altman recently traveled to the UAE seeking $7 trillion for infrastructure, a figure that exceeds the annual GDP of most nations. This creates a difficult financial cycle. Companies must burn through billions in hardware and electricity costs at an accelerating rate, hoping to achieve artificial general intelligence before their current funding runs out. Whoever secures the necessary infrastructure first gains a decisive lead. But with land and power running low, the standard strategy of simply raising more money is becoming increasingly difficult to sustain. The current power crisis traces back to 1993, when NVIDIA's founders decided to fix the blocky, pixelated graphics of early video games. They invented the GPU, the graphic processing unit. Standard CPUs solve problems in a sequence, one step after another. But a video game screen has millions of pixels that all need to update at once. NVIDIA designed the GPU to handle thousands of these parallel calculations simultaneously. AI models require this exact same massive parallel processing to function. However, when thousands of cores run at full capacity, their constant byproduct is heat, energy that must be moved away from the chip to prevent it from melting. The crypto mining industry managed this by moving their hardware to naturally cold environments like Iceland or Siberia, where geothermal or hydroelectric power was cheap and the air helped with cooling. AI cannot easily follow this path because of latency. Unlike a crypto transaction, an AI response needs to be instantaneous. This requires the servers to stay physically close to major cities, trapping them in urban environments that lack the water and power to cool them. AI companies are caught in a geographic squeeze. They need to be in the city for speed, but the city cannot handle the heat they produce. Instead of fighting for terrestrial permits, Elon Musk decided to merge SpaceX and xAI. His goal is to move the data centers themselves into orbit. Space provides a unique engineering environment. First, it solves the cooling problem. At -270 degrees Celsius, you don't need water. Simple radiators can expel heat directly into the vacuum of space. Second, it provides a stable power source. Above the atmosphere, solar panels have access to 24/7 unfiltered solar energy. Without clouds or a day-night cycle, they are roughly 40% more efficient than on Earth. Finally, it bypasses the land crisis. Earth's orbit provides vast amounts of available real estate without the need for city council approvals or decade-long environmental reviews. Moving high-density compute 300 miles up isn't about novelty. It is a response to the fact that the surface of the planet is running out of the resources required to sustain the next generation of AI. Other organizations are beginning to see the same logic. The European Union and startups like StarCloud are investigating orbital GPU clusters, and Google's Sundar Pichai has even mentioned the possibility of quantum clusters in space. The barrier is the cost of transportation. SpaceX's Starship is designed for high-cadence reusability, allowing it to deliver massive payloads and return to the launch tower to be caught by mechanical arms. This capability allows for the frequent heavy-lift launches required to build an orbital infrastructure. To handle the data transfer, Musk already operates Starlink. With 65% of all active satellites currently in orbit, he controls a pre-existing communications network that can link orbital servers to users on the ground. While other labs focus on improving algorithms, SpaceX has spent the last decade building the physical transportation and communication layer needed to move data centers off-planet. Merging xAI with SpaceX also changes the project's financial runway. While standalone AI labs rely on external investment rounds to pay for hardware, SpaceX's reported $8 billion in profit provides an internal source of capital that can help offset the massive costs of training frontier models. This is supplemented by the data from X. The platform provides a real-time flow of human conversation and imagery, which is used to train xAI's models, creating a self-sustaining loop of data and compute. This integrated ecosystem has pushed the combined entity's valuation to $1.25 trillion, positioning it as the most valuable private company in the world as it prepares for a potential IPO. If orbital data centers can overcome the hurdles of radiation and bandwidth at scale, they would provide a significant cost advantage. The billions currently being invested in terrestrial real estate would face a competitor that bypasses the limitations of the Earth's power grid entirely.